If a $30,000 machine depreciates 2% of its original value each year, find a function that expresses the machine's value v after t years. So they give me the names of the variables. V is the value of the machine. T is the number of years. There's nothing for me to define. They give it to me. So in a way, I can think of a function as a formula. What do? I want to come up with a formula to calculate the value of the machine after t years. So let's just look at some specific examples. What happens after 1 year? What is the value of the machine? Not what. How do I calculate the value of the machine? I don't care about a number. I care about how to calculate it. How do I calculate the value of the machine if 1 year has passed? It depreciates 2% of its original value. Yes? She says, take the original amount and subtract what?
30,000 times 0.0.
No? Yeah. I'm just looking at a specific, just 1 year. How do I do it? Because I'm trying to come up with a general. Good? I said after 1 year. Depreciation means it loses value. How much value? This much. 2% of 30,000. So I take 2% of 30,000 away. That's the value. There's no t. This is a specific number of years. So you can leave it like this, or you can write 30,000 times 0.98. Doesn't matter, whichever one you prefer. You can leave it like that. I don't want to calculate this. I'm trying to come up with a formula. Okay. I know it's obvious to some, but after 2 years, what is the value, or how do I determine the value of the machine after 2 years? Let's use the top one. Let's not use the bottom. I think top one, is the more acceptable one in terms of everyone understands the top one a little better. I have to read carefully. It might not be the most realistic question. The machine depreciates 2% of its original value every year. Now, depreciation doesn't actually work like that, but I have to use what the question gives me. So how do I find what the value is after 2 years? Well, let's start. What do I take away? Well, after 1 year, it's this. Oops. 2% times 2. Because it's this every year. So 2 years, this is how much I depreciate, I lose.
Is this supposed to be 0.02?
Oh, sorry. I did it. Yes.
So how would you rate it if it wasn't depreciating from its original value, but it's depreciating from its value that we have?
Okay, let's finish this guy first. So in general, after t years, I can write the formula any way I want, as long as it's correct. 0.02 times t. And I can leave it like that. I don't have to simplify it. It's more an issue of how do I calculate it. So she wants to know, it's probably the more realistic setting, how do things depreciate actually? It could be 2% of the value every time it loses 2% of its current value, not of the original value. Because then I'm going to have a zero very quickly. Yes?
For 2 years, can you also write 0.04?
I can. The reason I separate them is so that the formula becomes obvious and I see where the t should go. Because now I can't put these. The 0.04 here doesn't really tell me where the t goes. So all of this, depending on how comfortable you are with this, all of this, I'm trying to see a pattern for how to construct the general formula. That's all. So let's do example 4b, I suppose. If it depreciates 2% of its current value every year. Does that make sense? Current value? So if I have a value after 5 years, it's 2% of that current value that I lose a little bit. So I lose less and less every year. But it is steadily going down. What would I do? Well, maybe I'm not sure. Let's look after 1 year. Let's be sure. What is the value after 1 year? Now I think this guy's better. This guy's going to be a little bit nicer to work with. And these two are the same. Everyone happy that these two are the same? So by losing 2%, my new value is 98% in 3 years. Two ways to say the same thing. So after 1 year, everything's the same. Because my current value is the original amount. After 2 years, I take my current value, which is this. What do I do with it? I lower this by 2%. Or 98% of that current value. So I can simplify this a little bit. Oh, that's an 8. Wait, I have 2 of them multiplied together. Does that make sense?
Yeah. Can you just keep doing that then for multiple years?
So let's just check 1 more year. My question changed, so the formula is going to look different. Oh. What is my current value or of the previous year? It's that. Now I lower this by 2%. So it's 98% of this. So it's going to be times 0.98 cubed, because now I have 3 of them.
But why did we use 0.2 there? Yeah.
Because this looks a little better. I said, here, my question was different. The type of depreciation is different. So this first formula was okay to keep them separate. But now I have a different type of depreciation, 4b. That whatever its current value is at the start of year 10, at the end it loses 2% of that value, not of the original amount. So this guy is going to be a little bit more useful. It's just going to make my formula look a little nicer. It's going to get really messy if I keep this one. But these two things are take 2% away, I'm left with 98%. It's the same. This is just, it makes my formula a little nicer. So now I see the pattern, and I can say, for my changed question for B, I have 30,000 times 0.98 to the power of t. And the decrease is going to be different. It's going to be different. I have a different type. Maybe a more realistic depreciation, maybe. But regardless, I have to be careful. Don't make my own assumptions. Read what the question is telling you. If the question wants an unrealistic situation, I have to go with that. Any questions
So-
on what we just did? Yes.
What are we supposed to build on T?
So I say again?
Like, what is the assumption of what?
I'm trying to come up with the formula for
I
function.
like the other one better, it makes sense.
That was the original question. Then she asked, what if it's a more realistic type of depreciation? What do I do then? Different question. This is the answer to that question. I have two questions. The for and the example sheet, and our change. Suppose the weekly supply function for a pound of house blend coffee is P equal to Q over 48. What do these variables mean? We're almost done. One question. And we're done. What do these variables mean? P is the price, P for price. Q is the number that of pounds of coffee the supplier gives me. So the more they give me, I'm going to push the price up. But now just scan over these questions a little bit. In A, how many pounds will be supplied if the price is $8.39? How many pounds if the price is $19.49? And so on. So it makes more sense to me, they give me the price and I want the number of pounds. So I can change this and solve for Q essentially. Q is equal to 48P. And I'll use this. This is Q as a function of P. Meaning, give me the price and I'll tell you how many pounds I expect from the supplier. So based on the questions, looking at this function is much easier. But they're the same. So now I have a number of pounds with a quantity as a function of price. As the price increases, well, if I run a coffee shop and my price goes up, the suppliers are going to think, wow, we should give him more because he sells. So as the price goes up, the quantity that the supplier gives me goes up as well. Now I can answer, how many pounds of coffee will be supplied if the price is $8.39 per pound? So let's see this as a function. Function Q, my input is the price P. This is my name for the function. This is the rule, how I find the value, the output value. So the number of pounds that they're looking for is given by Q of, the price is $8.39, that's my input. How do I calculate the output? 48 times the input. What do I get? I don't know, 48 times this. 402.72. So if my price is $8.39, I expect them to supply me with 402, 403 pounds of coffee. So I have a rule that tells me how the price affects the supply. And it's a simple function. My point isn't here to make the function complicated, it's to get used to the input-output idea. B, how many pounds of coffee will be supplied if the price is $19.49? So the number of pounds of coffee will be given by Q as my function, my output. What is the input? 19.49. How do I find it? 48 times the input. What is the answer? 935.9. 5.2. That's how many pounds they're going to supply if my price goes up to 19.49. Now in C, I want to just take my time with number C because it leads very well into Friday's lecture. How does the amount supplied change as the price increases? They don't tell me the price increases from what to what, so let's just say if the price increases from, let's say, $8 to $9, what is the increase, or what is the change in the supply? Well, what is the Q of 8? 48 times 8. What is the Q of 9? 48 times 9. What is 48 times 8? I have no idea.
432.
432?
Oh wait, no, that's 48 times 9.
This one?
Yeah.
384.
What is the increase? Increase of 48, I think. This minus this? 48? So I just picked $8 to $9 increase. What if the price, we should do one more, the price increases from, what amount do you want? Give me an amount.
5.7.
It's a little low. I want something further away from this.
10 to 12.
That's pretty close.
No.
27.32.
5.
I just want an increase of $1.
5 to 15. 5 to 15.
$1 increase. $1.
21.22.
Okay, there you go. I wasn't clear. It's my fault. You can mention that when you talk to the dean. $1 increase changes the supply quantity by how much? That is the question. So Q of 21 equals 1. Q of 22 equals 1. What is Q of 21?
48 times 21.
Yes, which is 1,000 and... Oh, 8. What is the quantity with the price of 22? What is the increase? So it doesn't seem like which price I pick matters in terms of the increase of the supply. How do I show that in general? It doesn't matter. Whether I go from $8 to $9, $21 to 22, if the price increases from, let's be more general, P dollars to P plus $1, what is the increase in the supply? Well, Q of P is 48P. Q of P plus 1, now this is my input. The rule says take the input and multiply it by 48. What do I get? 48P plus 48. So if I increase by $1 in general, what is the increase in the supply? From 48P to 48P, P plus 48. I have an increase of 48. So I can show in general that regardless of the price that I pick and then go $1 up, the increase is always 48. That is a property of the type of function that I'm looking at. Where's the function? I erase the function. It's a property of this function. It's called a linear function. Straight line function. And it always has the property that if I increase my independent variable by 1, the change is always the same in my output or my dependent variable.